As we look at starting chapter 9, we're going to be looking at a different kind of graph called a scatter plot. Different ways to use them, interpret them, all that kind of stuff. So today we're just going to start with the basics of what a scatter plot is and making it. So let's look at activity 1, constructing a scatter plot. It says the weight x in ounces and the circumferences c in inches of several sports balls are shown. So a basketball is 21 ounces in weight and it's 30 inches all the way across. And you could do that, look at that for every single ball they have here. So A says choose a scale for the horizontal axis and the vertical axis of the coordinate plane below. So if you look, here's your coordinate plane. The x-axis is the weight. So if I look at the weights of these, I have 21. 21 looks like it's the biggest. The smallest one looks like it'll be the racquetball at 1.4. So we need to go from 1 to 21. And if you notice, you don't have that many spaces on your graph. So what I would probably do is maybe go by 2s along the bottom here. So as I go ahead and try to start writing all of these down, I'll just go by 2s all the way across. Oops, it should be 20. Okay, and then for the y-axis, the circumference, looks like my biggest one again is the volleyball, and that's at 30. Smallest is probably going to be the golf ball at 5.3. So really we need to go from 5 up through 30. Well, if I go by 5s, my graph would only come up to this line right here. And I wanted to go as far to the top as I can. So let's say we go by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30 would be the very top. So that's what I'm going to do. I'm going to go by 3s. Okay. Then for B, it says write the weight and the circumference of each ball as an ordered pair and then plot those on the graph. So the weight is going to come first. Oops. So let's say the basketball. That ordered pair would be 21, 30. The baseball would be 5, 9. Golf ball, 1.6, 5.3. Let's see, the soccer ball, 16.28. Tennis ball, 2.8. The racquetball, 1.47. The water polo ball, 15.27. Softball is 7.12. And the volleyball is 10.26. So then I'm just going to go through and I'm going to plot these. So first I have 21, 30. So 21 is going to go a little off my graph. I realize that. And right up at the top. Okay, and then 5, 9. 1.6 and 5.3. So again, this is just going to have to be an estimate. Somewhere about right in there. 16.28 over 16 and up all the way to 28. 2.8. 1.4 and 7. Be about right in there. 15.27. 7.12 and 10.26. About right there. So you see, this is a scatter plot. Okay, you have just random dots thrown on the graph. They don't form any kind of line, or they're not in an exact straight line. But what we're going to be looking at, start looking at in this chapter, is kind of the relationship that they follow. So if you look at C, it kind of leads to that. It says, describe the relationship between weight and circumference. So if you notice, the smaller a ball is, or the lighter it is, the smaller it is. The heavier it is, the bigger it is. So that's going to be our relationship. The smaller the weight, the smaller the circumference. And then it says, are any of the points close together? So up on my graph, I'm just going to kind of circle where these little clusters are. Okay, there's a cluster of points right down here, cluster of points really right there. Okay, we'll look more into clusters a little bit later, but that's where the points are kind of grouped together. Now I'm going to keep my graph right here, but if you guys flip to the next page on part D, it says, do you think this graph could be described as positive, negative, or as having no relationship whatsoever? And then is it linear or nonlinear? So as we look at this, okay, if it's positive, it's going to be going up. If it's negative, it would be coming down and to the right. So for this one, and you can write this on part D, we would say this one would have a positive relationship because everything is kind of going up and to the right. Now, whenever they say linear and nonlinear, they are not looking specifically, do they fall in a line or do they not? With scatter plots, it's more of a general area. Does it look like the lines, or I'm sorry, the points follow somewhat of a line going up? Okay, or are they just scattered everywhere? Okay, so in this case, if you look at these points on the line, or points on the graph, they do kind of follow a linear pattern. They're all kind of going up in the same direction. So we would say this would be a linear relationship with the scatter plot. Then, if you look at E, again, I'm just going to keep this writing here and come back to it. It says a bowling ball has a weight of 225 ounces and a circumference of 27 inches. Describe the location of the ordered pair that represents this data point in the coordinate plane, and how does it compare to others? So if we come back and we look at the graph, if the weight was 225 ounces, notice our graph only went up to 20. Okay, so our bowling ball is going to be clear, way off the page, way down there, but it's only going to have a circumference right up here at the top of our graph. Okay, so it would not follow the relationship that these other points followed because the weight is so heavy. So I'm going to come down to E. Okay, how does it compare to others? So on E, here's what we're going to say. The bowling ball weighs a lot more but it's close to the same size. It would not follow the trend in the graph. Okay, so it doesn't really follow the consistency that those other balls followed. All right, so moving on to activity 2. It says the table shows the number of absences and the final grade for each student in a sample. So we have the number of absences that they have and then their final grade that they received in that class. So A says to write the ordered pairs from the table and then plot them on the coordinate plane. So you could write the ordered pairs right out here to the side. Okay, we would have 0.95, 3.88. Basically, all of these are an ordered pair. And we could go all the way down. Now, I'm going to skip out on that part. We're just going to go straight to plotting them. So 0.95 over 0 up to 95, over 3 up 88, over 2 up 90, over 5 up 83, over 7 up 79, over 9 up 70, over 4 up 85, over 1 up 94, over 10 up 65, and then over 8 up 75. So you may want to take a minute, pause the video if you need to get all those in there. Now, B says describe the relationship between absences and final grade. So it's clearly showing the more absences, the lower their grade. Okay, now how is this relationship similar to the one in activity 1 between the weight and circumference? They both follow a linear pattern. And then how are they different? Well, notice with the one in activity 1, your graph went up and to the right. This one's going down and to the right. So this is a negative relationship. Unlike number 1. It was positive. Okay, and you can see your graphs going 2 different ways. Now, moving on to the next page. A student has been absent 6 days. Use the data to predict the student's final grade. So I want you to take a minute, look back at your graph, and go ahead and make a prediction on C. And then we'll move on. Okay, activity 3. Match the data sets with the most appropriate scatter plot. Explain your reasoning. So we have the month of birth and the birth weight for infants at a daycare. Now, if you think about a month you were born and how much you weighed, there is really no correlation to those whatsoever. Your weight and your height could be, but not when you were born. So this is going to be graph 2, because notice it's kind of scattered everywhere. B is the quiz score and a test score of each student. So if you got a higher quiz score, what's going to happen to your test score? It's going to be higher. So this is going to be this graph right here. And then C, the age and value of laptop computers. So think about your laptops that you have. When you got them, they were brand new. You had them for 0 days, they were brand new. Their value was high. And as you've worn them out, their value has decreased. So that would be the third graph right there. So we've looked at scatter plots and how they're kind of just a bunch of dots arranged either in an order or just scattered everywhere. So your assignment with this is going to be over on the next page, page 188, to complete the 9.1 practice.